Hi guys, welcome to your 2.1 notes on solving one-step equations. By the end of the day, you'll be able to solve one-step equations with one variable. So let's just jump right in, shall we? So let's say we have this equation, x plus 5 equals 33. So what's happening here is we have some number x and we don't know what it is. But we know that when we add 5 to it, we get 33. So there's some number x plus 5 is 33. So we don't know what that number is. We represent it with a variable. In order to find out what x is, we're going to get it all by itself. That's our key idea, is we want to isolate the variable to get it all by itself, to get it alone. So in order to do that, we need to get rid of this plus 5. We undo a plus 5. And what will undo plus 5, we call that the inverse operation. The inverse is like the opposite. Whatever will undo something. So to undo adding 5, that's subtract 5. Now, if you are like me and you like visuals, I have this diagram here for you. So we know that our total, x plus 5, whatever that is, that's equal to 33. So the whole thing that we have here is 33, and then we have two parts added together, x plus 5. So that's, 33 equals x plus 5. And what we're going to do is we're going to take away this 5. We're going to subtract 5. So we subtract 5, but we also need to subtract 5 up here to find out what x is. So we subtract 5 on both sides. 33 minus 5 is 28. So we get that 28 is x. So there you go. All right. Now let's come up with a new one. So we have x plus 15 equals 40. So we know our whole diagram, the whole length is going to be 40. And then we have 15 over here. And then whatever x is, we know that x plus 15 is going to be 40. So we have x plus 15 equals 40. And we want to get rid of this 15. So we're going to take away 15 from 40. So if we take away 15 from both sides, that tells us that x is 25. So what was the first step in solving this equation? Well, we wanted to subtract 15 from both sides. I often see students knowing to do this minus 15 part, but they forget to do it from both sides. And the reason we subtract from both sides is because we want to create, sorry, there's something on my screen. Okay, anyway, we want to create something that's called an equivalent equation. An equivalent, these always come in pairs. So equivalent equations are things that are equal. That's where the equivalent comes from. Right? They have the same solutions. For example, we just had up here, we had x equals 25. That's an equation. X equals 25 is equivalent to x plus 15 equals 40. They have the same solution, which is x equals 25. Another equivalent equation is if you have any number, if you have any number equal to another number and you add 8 to both sides. You have a plus 8 equals b plus 8. So long as a equals b, you do the same thing to both sides of the equal sign, they're going to be equal to each other. And you guys, that brings us into 2 properties of equality. 2, or are we doing 4 today? We're going to do 4 today. Nice. Okay. So the first one is called the addition property of equality. And what that means is when you add the same number to both sides of an equal sign, you get an equivalent equation. So for example, over here, if you have x minus 3 equals 2, we know that x minus 3 and 2 are the same. And as long as you add 3 to both sides, those are still going to be the same number. This would undo each other, so that crosses each other out. And that tells us that x equals 2 plus 3 is 5. So x equals 5. Isn't that so cool? So cool. So the official algebra term is if A equals B, then A plus C equals B plus C. We call this the addition property of equality because you're adding and they are still equal. Using that as a don't worry about the drawing. We're not going to do that. Using that as a starting point, what do you guess is the subtraction property of equality? Instead of adding C, here we subtract C. So if you have two numbers that are equal to each other, if you subtract the same number, those expressions are still going to be equal. For example, if you have, again, that x plus 3, we had x minus 3, didn't we? So if you have that x plus 3 is equal to 2, then you subtract the same number from both sides. Well, these plus 3 minus 3, these will undo each other, leaving you with just x. 2 minus 3 is negative 1, so that tells us that x equals negative 1. Isn't that great? That's awesome. So you can add and you can subtract to find equivalent equations. Now we're going to use this today to solve equations. So our ultimate goal, our key idea of the day, is that in order to solve the equation, you want to isolate the variable. To isolate means get it all by itself. To get it all alone on one side of the equation. So an isolated variable is when you have like x by itself, say x equals 5. Or you have like a equals negative 28. Here, these are isolated because the variable is all by itself on one side of the equation. It doesn't have to be on the left side. You could have like 3.2 equals y. And as long as you have just the variable all by itself on one side of the equal sign, that's totally fine. Now, our key idea of the day, I'm gonna draw a light bulb because it's your key idea. Your key idea is that you want to undo everything that's happening to the variable. So you're going to isolate the variable. You're going to get it all by itself by undoing what's happening to the variable. We call these inverse operations. To do the opposite of something is called the inverse operation. Right? Examples, like non-math examples of inverse operations are things like tying and untying, like tying a bow and untying a bow, or opening a door and closing a door. Math examples, the opposite of add is subtract. By opposite, I mean the inverse. The inverse of multiply is divide. The inverse of squaring a number is taking the square root of a number. That's so fun. So fun. So, if we want to solve this equation, remember our goal is we want to get x all by itself. We want to isolate x. So how are we going to do that? Well, let's undo what's happening to x. Here we've got a plus 13. So to undo that plus 13, we're going to do the inverse of that. We're going to subtract 13. But remember, you need to subtract 13 from both sides. That way, the 13s cancel each other out. So we're left with x equals 14. And this is solved because we have the variable all by itself. So x equals 14. Now here, remember our goal is to get b all by itself. What's going to undo what's happening to our b? Well, we've got a minus 3, so to undo the minus 3, we're going to add 3 to both sides. On the right, those will cancel out, giving us just b all by itself. That's the whole goal. Yay, awesome. Negative 7 plus 3, negative 4. So we got b all by itself, and it's negative 4. Super duper. So that's with addition and subtraction. We also have this. This also works with multiplication and with division. So the multiplication property of equality works exactly the same way. If you have some number a equal to another number b, and you multiply the same number on both sides, they're still equal. So if a equals b, then a times c is equal to b times c. Cool. So over here, we have that x over 3 is equal to 2, and it's multiplied both sides by 3, it's still going to be the same. Here, this divide by 3 and this times by 3, those will undo each other, giving us that x equals 6. The same thing works with division. Here we have two expressions equal to each other. We have 5x equals 20, and 5x divided by 5 is equal to 20 divided by 5. These 5's will undo each other, giving us x equals 20 divided by 5 is 4. So what that looks like in a generic algebra sense is if we have two numbers, a equal to b, then we divide them by the same thing, they're still equal. So as long as a is equal to b, then a divided by c is going to be equal to b divided by c. Again, we're not going to do these drawings. So let's put this into practice. Remember, what is our goal to solving an equation? We want to isolate, oh, wrong color. We want to isolate the variable. And how are we going to isolate the variable? We want to undo what's happening to our variable. So here, we want to get x all by itself. What's happening to our x? Well, it's multiplying by 4. So we need to divide by 4 on both sides. The 4's will cancel out, giving us that x equals 16. Over here, what's happening to this guy? Well, it's the opposite. It's dividing by 4. So to undo dividing by 4, oh yeah, we want to get this all by itself. So to undo or divide by 4, we need to multiply by 4 on both sides. And that gives us that x equals negative 36. And then finally, oh, we've got this really funky one. We want to get x all by itself. And what's happening to our x? Well, it's 3/4 times x. So we could divide by 3/4 on both sides, but you guys, dividing by fractions is so hard. There must be another way. There must be a better way. So instead, we can multiply by its reciprocal. We do 4/3 times 3/4. So we multiply by 4/3 on both sides, and these will cancel out. Look, the 4 reduces with the 4, the 3 reduces with the 3, giving us just an x. Nice, that's what we want. We want to get this x all by itself. Cool beans. And then we got to do a little tricky trick. 6 times 4 is 24. 1 times 3 is 3. That gives us 8. Oh, hey, that's my favorite number. I didn't even do that on purpose. Nailed it. Okay. Now, that's great and all, but when are we going to use this in real life? Well, let's find out. Okay. So you have this toucan, like your Lucky Charms and stuff, and you know that the length of the average toucan is about 2/3 the length of a blue and yellow macaw. Oh, we'll make it yellow. These are all birds, guys. Okay, so toucan, it's like Fruit Loops, Toucan Sam. And blue, yellow macaw, it's like a parrot that's blue and yellow. Now you know that toucans are 24 inches long. Why do you know this? Because I told you. So what's the length of the average macaw? Macaw. Because it's a parrot. Get it? Well, let's find out. What do we know? We know that toucans are 24. So we can say 24. Oh, is means equals. 24 equals, and then 2/3 the length of the average macaw. Well, we don't know what that is, so we're going to call it m. So we put this into math language right here. So we know our toucan is 2/3 the length of the average blue and yellow macaw. But we know toucans are 24 inches long. And a macaw, we don't know. We need to find that out. So we put this into a math sentence. We said T, which is 24, so 24 equals 2/3 of m. So now that we've got this amazing multicolored equation, I'm going to get rid of the colors so it's not so distracting, and then we'll solve it. So we want to find out what m is. We want to get this m all by itself. So let's undo what's happening to the m. What's happening to our m? Well, it's got 2/3 times m. So we want to multiply times 2/3 to get rid of it. But remember, according to the multiplication property of equality, you need to multiply times 2/3 on both sides. So that's great, because the 2 and the 2, oh, no, not times 2/3, I lied. You need to multiply, not times 2/3, you need to multiply times 3/2. 100% my bad. It's in my notes right in front of me, and I still did the wrong thing. So the 2 and the 2 will cancel out, the 3 and 3 will cancel out, giving us just m on one side. And then 3 times 24, oh, you guys, I'm so lazy, I'm going to reduce beforehand. This 2 and the 24 are both divisible by 2. So it'll give us 3 times 12 on top, divided by 1 on bottom is just nothing, so 36. Nice. So 36 is m. So that means the average macaw is about 36 inches long. Or 36 inches is also equal to 3 feet. So that's fine as well. Awesome. Key idea is right here. You need to get the variable all by itself, so undo what's happening to the variable. I hope you have a wonderful time on your homework.